One of the math skills we'll be using, maybe more than any other, in this course is trigonometry. So I wanted to review that a little bit. This is another thing that you probably know, but it would be useful to see a little review because of how much you're going to be using it. So trigonometry is the study of dealing with right triangles. If you are given some information about a right triangle and you don't know other information, how do you reconstruct the information that you don't know? So for example, let's say that I draw a right triangle here. Okay, let's say here's a right triangle. And the right angle is down here, of course. Let's try to mark that. And let's say that you're given some information about it. Maybe the information you're given in this case is that this angle over here is 25 degrees. And maybe you know that this side is 8 in length. Just forget units, we'll just say it's 8 in length. How do you figure out what is this side over here? Say call it A, and what is this side over here? Say call it B. Okay, so when you have this kind of problem, the main starting point is you have 4 basic tools at your disposal in trigonometry. You've got the Pythagorean Theorem, and the Pythagorean Theorem says that a squared plus b squared equals c squared. And the important thing to remember in Pythagorean Theorem is that c is always the side opposite the right angle. C is always the hypotenuse of the triangle. And then you've also got sine, cosine, and tangent. So you've got sine of theta, cosine of theta, and tangent of theta. Now, I'm sure you learned the mnemonic for how to remember what sine, cosine, and tangent are equal to. But if you haven't, the way most people remember this is so ka toa, which stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. And that helps you remember these 3 equations here, that sine of theta is opposite over hypotenuse. And let's stop for a second here. What does that mean? What is opposite? And what is adjacent? And what is hypotenuse? There's always going to be one particular angle in the triangle that you have your eye on. In this case, the 25-degree angle. So as soon as I have my eye on this 25-degree angle here, I now have like a preferred angle in the triangle over here. And you'll notice that one side of the triangle is going to be on the opposite side of the triangle from that 25-degree angle. So that's the opposite side. One side is going to be a part of that 25-degree angle. So that's going to be the adjacent side. And one side is always going to be opposite of the right angle, which is your hypotenuse. So that's the meaning of those 3 things. So when we say opposite and adjacent, we're talking about opposite to theta, the angle that you have your eye on right now, and adjacent to theta. And then hypotenuse is a special case. So sine is opposite over hypotenuse. Cosine is running out of space here. Sorry if this is messy. Adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, So like, how do we use that information? So for example, let's say that I wanted to solve for side B, let's say. Suppose for the question I'm solving, I want to solve side B. What I would say to myself is, first of all, what's the known information? In this problem, the hypotenuse is known. The hypotenuse is that 8, and my theta is going to be that 25-degree angle. So now I have to ask myself, what is side B? Side B is the side adjacent to the 25-degree angle. It's adjacent because it's touching. It's literally touching. Right here, the 25-degree angle actually touches side B, which makes it adjacent. So you can see here, I have hypotenuse, theta, and adjacent. So that tells me that I'm going to want to use cosine, because cosine has these three. So then I would say, for instance, cosine of theta is adjacent, which is B, over hypotenuse, which is 8. And let me plug in theta as well. Theta is 25. So then I can get B is 8 times cosine 25. Which is, incidentally, punch that in, 7.25 is what I got. What if we wanted to solve for A? Since A is opposite of the 25-degree angle, you could do it with sine of 25. This is the method I would recommend. So that means A is 8 times sine of 25. So you put in your calculator, sine of 25 times 8, and I got 3.38. Or you could also, if you know side B already, you could plug into tangent if you prefer, or Pythagorean theorem. I would recommend solving things right from the known information if you can, so that way if you make a mistake, the mistake won't cause all of your other things to be wrong. Anyway, that's how you handle it. So a few notes about this: make sure that you understand what is the adjacent side and what is the opposite side, what's meant by those terms. If you don't fully understand how I knew that B was the adjacent side and A was the opposite side, definitely ask about that and get that cleared up, because that's going to be a really, really, really important point that will cause you to make mistakes throughout the whole course. And the other thing is, like in the triangle I drew here, I drew like a weird rotated triangle where 8 is actually the horizontal side, and yet it was the hypotenuse. Because for hypotenuse, what matters is where is the right angle located. The hypotenuse is opposite of the right angle. So other than that, it's pretty straightforward. You'll get a lot of practice doing this over the course of the semester.